Hi students, in last lecture we have studied two questions from exercise 8.1. Now the third question from the same exercise. Third question is, find all the points of the discontinuities of f of x is equal to step x on the interval -3 to 2. This interval is open interval, means -3 and 2 are excluded from the domain of the function. Now look at the function. The function is f of x is equal to step x, where x is from the interval -3 to 2. Now we know that this function step x, we have already discussed in previous lecture about the function step x. Step x gives us the different values in the one interval of two integers. Means from 0 to 1 it will gives us always value 0. From 1 to 2 it will always gives us the value 1. Means here we can redefine this function f of x as f of x can be written as is -3 for the value -3 is less than x is less than 2. -2 means for all the points lie between -3 to 2, the function will always gives us value -3. It will be -2 for all the values of x lie between -2 to -1. Means for step of -2 it is also -2, and from -1.9 -1.5 for all that values we will get always value -2. It will gives us value -1 from -1 is less than or equal to x is less than 0. It will gives us value 0 for all the values between 0 to 1, and it will gives us value 1 from 1 is less than or equal to x is less than 2. Means this is a redefining function step x for this interval -3 to 2. Observe this carefully. This step function always gives us value -3, mean between the values from -2 to -3. -3 and 2, these are not in the interval because this interval is open interval. Now for every interval you can observe that this function is a constant function. Means here if you observe, for example, let x is equal to -2 we will check, then we can say that limit of f of x as x tends to -2 minus, means LHL अगर हम फाइंड आउट करते हैं तो इसकी वैल्यू हमें मिलेंगी -3, एंड लिमिट ऑफ f of x as x tends to -2 प्लस, इसके लिए -2 प्लस यानी -2 से ज्यादा, उसके लिए फंक्शन की वैल्यू -2 है तो ये आएगा -2. तो हम यहां पे क्या ऑब्जर्व करते हैं कि लिमिट ऑफ f of x as x tends to -2 minus is not equal to limit of f of x as x tends to -2 plus. Hence we can say that f of x is discontinuous at x is equal to -2. जैसे हम -2 के लिए इस फंक्शन को डिसकंटिन्यूअस दिखाया, वैसे ही अगर हम -1 के लिए लिमिट निकालते हैं तो इसका LHL और RHL -1 के लिए भी अनइक्वल आने वाला है, वैसे ही 0 के लिए और 1 के लिए. Then we can say that similarly we can say that f of x is discontinuous at x is equal to -1, x is equal to 0 or x is equal to 1. Hence we can say that points of discontinuity are x is equal to -2, -1, 0 and 1. These are 4 points in this interval -3 to 2 where the function step x is always discontinuous. As question says that find all the points of discontinuity of this function, we have here all that points -2, -1, 0 and 1. Now look at for question number 4. Discuss the continuity of the function f of x is equal to step of 2x plus 3 at x is equal to -3/2. As you already know that step function is always continuous on its respective domain, or step function, not step function, modulus function. I will recorrect it. Discuss the continuity of the function f of x is equal to mod of 2x plus 3 at x is equal to -3/2, and we know that modulus function is always continuous at every point on its domain. Hence we can say that this function 2x plus 3 is also continuous at x is equal to -3/2. Means orally we can say that this function is continuous. But as we want to discuss the continuity, we must have to redefine this function again, because step function always changes for less than and greater than values. If for this value of x, this will give us 0 value. If you observe, if you substitute the value x is equal to -3/2 here in this function, then 2 into -3/2, it becomes -3 plus 3 means 0, and mod of 0 is always 0. But here we define this function using the definition. By the definition of mod x, we can say that mod x is equal to -x for all the values of x less than 0 and is equal to x for all the values of x greater than or equal to 0. Using this definition, we can redefine this function. Therefore, f of x is equal to step of mod of 2x plus 3 for x is not equal to -3/2 can be redefined as f of x is equal to minus of 2x plus 3 for all the values of x which are less than -3/2 and is equal to 2x plus 3 for all the values of x greater than or equal to -3/2. As we have redefined this function, now we are going to find left hand side limit and right hand side limit of this function. Limit of f of x as x tends to -3/2 minus is equal to limit of function is minus of 2x plus 3 as x tends to -3/2 minus. Now substitute this value. It is minus of 2 into -3/2 plus 3, that is minus of -3 plus 3. This is nothing but 0. Similarly, limit of f of x as x tends to -3/2 plus is equal to limit of 2x plus 3 as x tends to -3/2 plus. Hence we have, if you substitute this value, we'll get again -3 plus 3 which is equal to 0, and f of -3/2 is also 0. Hence we can say that this limit of f of x as x tends to -3/2 minus is equal to limit of f of x as x tends to -3/2 plus is equal to f of -3/2, and hence we can say that that function is continuous function. Means f of x is continuous. We can write here also as I have not placed there, I can write f of x. Therefore, we can say that f of x is continuous at x is equal to minus 3/2. Hence, we have studied this question number 3 and 4. Now we are going to study question number 5. Now after question number 4, look at for question number 5. Question says that find the points at which the function is discontinuous or discuss the continuity of the given function at a point indicated against it. Now f of x is given in first question. F of x is given root of x minus 1 minus x minus 1 raised to 1 by 3 upon x minus 2 for x is not equal to 2 is equal to 1 by 5 for x is equal to 2 at x is equal to 2. Now look at the function. We are going to find the limit of this function and we have to check whether this limit of the function is equal to its value or not. For that, limit of f of x as x tends to 2 is equal to limit of root of x minus 1 minus x minus 1 raised to 1 by 3 divided by x minus 2 as x tends to 2. If you try to substitute this value here in this function, we'll get 2 minus 1 is 1, square root of 1 is 1, 2 minus 1 is 1, cube root of 1 is also 1, 1 minus 1 is 0, divided by, put x is equal to 2, 2 minus 2, 0 means it is giving 0 by 0 form, which is indeterminate form. Now, in such cases, limit can be exist, and if limit can be exist, we can find its limit. Now, observe the functions carefully. I will rewrite this function, limit of x minus 1, square root of x minus 1, it can be written as x minus 1 raised to 1 by 2 minus x minus 1 raised to 1 by 3 divided by, I can write this x minus 2 as x minus 1 minus 1 as x tends to 2. Now we are using substitution method here. Put x minus 1 is equal to h. Therefore we have x is equal to 1 plus h. As x tends to 2, if you substitute 2 here, 2 minus 1 is 1, means h must tends to 1. Means this limit converts as limit of h raised to 1 by 2 minus h raised to 1 by 3 divided by h minus 1 as h tends to 1. We have replaced everywhere this x minus 1 by h. Here h raised to 1 by 3, this is h minus 1. And x tends to 2, it becomes h tends to 1. Now remember that formula, limit of x raised to n minus a raised to n divided by x minus a as x tends to a is equal to n into a raised to n minus 1. Using that formula, to use that formula, we have to adjust minus 1 here. Now, it becomes limit of, we can write it is h raised to 1 by 2 minus 1 minus h raised to 1 by 3 plus 1 divided by h minus 1 as it tends to 1. Now, using algebra of limits, we can separate it into two limits. It is limit of h raised to 1 by 2 minus 1 divided by h minus 1 plus minus, taking minus 1 common, minus common from this, it is limit of h raised to 1 by 3 minus 1 divided by h minus 1 as it tends to 1. Now, apply the formula. Using the formula, limit of x raised to n minus a raised to n divided by x minus a as x tends to a is equal to n into a raised to n minus 1. Using this formula, we can find its limit, that is, it becomes the value of n is 1 by 2, means 1 by 2 into value of a is 1 means 1 raised to 1 by 2 minus 1. If you can not understand, we can write this 1 as 1 raised to 1 by 2 also, or this 1 as 1 raised to 1 by 3 also, because square root of 1 and cube root of 1 itself it is 1. Means to match this with the formula, we can rewrite these terms like that also. And minus 1 by 3 into 1 raised to 1 by 3 minus 1. But we know that any power of 1, it results in 1 again. Always means it is 1 by 2 minus 1 by 3. By solving it, we'll get 3 minus 2 upon 6, that is 1 by 6. This is the value of limit of function f of x as x tends to 2. And value of the function is given 1 by 5. F of 2 is given 1 by 5. Means here we can observe that limit of the function, limit of f of x as x tends to 2 is not equal to f of 2. Hence we can say that f of x is discontinuous at x is equal to 2. It is discontinuous at x is equal to 2. 2 के लिए फंक्शन डिसकंटिन्यूअस हो गया. क्वेश्चन नंबर 5 का फर्स्ट सब क्वेश्चन हमने सॉल्व किया. अब जाते हैं दूसरे क्वेश्चंस के लिए. क्वेश्चन नंबर 5 का सेकंड क्वेश्चन है f of x is equal to x cube minus 8 upon root of x plus 2 minus root of 3x minus 2 for x is not equal to 2 and is equal to minus 24 for x is equal to 2 at x is equal to 2. Means this shows that, this says that discuss the continuity at x is equal to 2. Here also the function is same for all the values of x less than and greater than 2. Hence we are no need here, there is no need to find left hand side limit and right hand side limit. We are just finding the limit of the function as x tends to 2 directly. Therefore limit of f of x as x tends to 2 is equal to limit of x cube minus 8 divided by under root of x plus 2 minus under root of 3x minus 2 as x tends to 2. If you observe this function carefully, as root are present in the denominator, we can use here rationalization method. You rationalize the denominator, will get simplified it. Limit of x cube minus 8 divided by this under root of x plus 2 minus under root of 3x minus 2 into its conjugate pair root of x plus 2 plus under root of 3x minus 2. Means here again we have to multiply this bracket to the numerator also. This is root of x plus 2 plus root of 3x minus 2. Means while rationalizing the denominator, we have multiplied numerator as well as denominator by the conjugate of denominator as x tends to 2 is equal to limit of, we'll rewrite this bracket in another form, this as x cube minus 2 cube, x cube minus 2 cube into second bracket root of x plus 2 plus root of 3x minus 2 divided by taking product of these two brackets, it is x plus 2 minus 3x and minus into minus it becomes plus 2 as x tends to 2. Now here we can use the formula x cube minus 2 cube. For this we can use the formula a cube minus b cube. A cube minus b cube का क्या formula होता है? Using a cube minus b cube is equal to a minus b into second bracket a square plus ab plus b square. Using this formula we can factorize this term as limit of, in first bracket आएगा x minus 2, दूसरे bracket में आएगा x square plus 2x plus 4 और ये वाला bracket as it is रहेगा. root of x plus 2 plus root of 3x minus 2 divided by this term becomes this x minus 3x means minus 2x plus 4 as x tends to 2. Now look at this. Here the term is minus 2x plus 4, from which minus 2 can be taken common, is equal to limit of numerator remains as it is, x minus 2 into x square plus 2x plus 4 into root of 3x root of x plus 2 plus root of 3x minus 2 divided by minus 2 into bracket x minus 2 as x tends to 2. Now this x minus 2 and x minus 2 get cancelled. Why we can cancel it? As x tends to 2, x is not equal to 2 और x अगर 2 नहीं है तो x minus 2 0 नहीं है, इसलिए हम इसको कैंसिल कर सकते हैं. बाकी टर्म्स में हम लिमिट की वैल्यू डायरेक्टली लिख सकते हैं. हम लिखेंगे लिमिट ऑफ एक्स स्क्वायर प्लस 2x प्लस 4 इंटू रूट ऑफ x प्लस 2 प्लस रूट ऑफ 3x माइनस 2 डिवाइडेड बाय माइनस 2 एज x टेंड्स टू 2. अब ये इनडिटरमिनेट फॉर्म नहीं है. अब अगर हम x की वैल्यू 2 रखेंगे तो ये 0/0 का फॉर्म नहीं देता, तो हम x की वैल्यू 2 डायरेक्टली डाल सकते हैं वहां पे. ये 2 का स्क्वायर यहां पे आएगा 4 प्लस 2 इंटू 2 आएगा 4 प्लस 4 इंटू ब्रैकेट स्क्वायर रूट ऑफ 2 प्लस 2 4 प्लस स्क्वायर रूट ऑफ 3 इंटू 2 6 माइनस 2 यानी 4 डिवाइडेड बाय माइनस 2 दैट इज इक्वल टू 4 प्लस 4 ये आएगा 12 इंटू ये आएगा 2 प्लस 2 यानी आएगा 4 अपॉन माइनस 2, तो ये आएगा माइनस 24. तो ये हो गई आपकी लिमिट ऑफ एफ ऑफ एक्स एज एक्स टेंड्स टू 2 की वैल्यू. और एफ ऑफ 2 भी दिया है आपको, एफ ऑफ 2 भी दिया है माइनस 24. यहाँ पे एफ ऑफ 2 इज माइनस 24. हेंस वी कैन से दैट लिमिट ऑफ एफ ऑफ एक्स एज एक्स टेंड्स टू 2 is equal to f of 2. Hence we can say that f of x is continuous at x is equal to 2. x is equal to 2 के लिए ये वाला फंक्शन कंटिन्यूअस हो गया. क्यों कंटिन्यूअस हो गया? क्यों? तो लिमिट की वैल्यू और फंक्शन की वैल्यू सेम है, तो फंक्शन कहेंगे कंटिन्यूअस एट दैट पॉइंट. नाउ फॉर क्वेश्चन नंबर, अब क्वेश्चन नंबर 3 देखो. f of x is equal to 4x plus 1 for x is less than or equal to 8/3 and 59 minus 9x upon 3 for x is greater than 8/3 at x is equal to 8/3. अब इसके पहले जो दो क्वेश्चन सॉल्व किए थे उसमें और इसमें क्या फर्क है? तो फंक्शन डिफाइन किया थोड़ा डिफरेंट फॉर्म में है. पहले दोनों क्वेश्चन में फंक्शन के सामने यहां x इज नॉट इक्वल टू 2 ऐसा लिखा था, या x इज नॉट इक्वल टू a, और जो सेकंड फॉर्म में दिया था यहां पे दी थी फंक्शन की डायरेक्ट वैल्यू. इसलिए हमें वो दोनों क्वेश्चन में लेफ्ट हैंड साइड लिमिट और राइट हैंड साइड लिमिट ये निकालने की जरूरत नहीं पड़ी. लेकिन अब इस क्वेश्चन के लिए आपको LHL और RHL दोनों निकालना पड़ेगा, क्योंकि जो पॉइंट के लिए हमें कंटिन्यूटी डिस्कस करनी है उसके लेस देन के लिए और उसके ग्रेटर देन दोनों के लिए फंक्शन डिफरेंट है. अगर हम ठीक से ऑब्जर्व करेंगे तो दोनों फंक्शन ये पॉलिनोमियल फंक्शन है. पॉलिनोमियल फंक्शन तो हमेशा कंटिन्यूअस होता है, लेकिन यहाँ पे दोनों फंक्शन अलग अलग दिए हुए हैं और जो पॉइंट के लिए हमें डिस्कस करना है उसके लेस देन और ग्रेटर देन के लिए सेपरेट है. तो हम यहाँ पे LHL और RHL निकालेंगे. LHL निकालेंगे तो लिमिट ऑफ f of x as x tends to 8/3 माइनस, और 8/3 माइनस के लिए ये फंक्शन है लिमिट ऑफ 4x plus 1 as x tends to 8/3 माइनस. अब x की वैल्यू हम यहां पे सब्स्टिट्यूट करते हैं बिकॉज इट इज अ पॉलिनोमियल फंक्शन. वी कैन सब्स्टिट्यूट इट डायरेक्टली. दैट इज इक्वल टू लिमिट ऑफ 4 into 8/3, sorry, डायरेक्टली सब्स्टिट्यूट करते हैं 4 into 8 by 3 plus 1 that is equal to 32 upon 3 plus 1. If you take cross multiplication, here we have 35 upon 3. Its value is 35 by 3. Now for RHL, right hand side limit, we have limit of f of x as x tends to 8 by 3 plus, that is equal to limit of function 8 by 3 plus के लिए 59 minus 9x divided by 3 as x tends to 8 by 3. We can write it as limit of 59 by 3 minus 3x as x tends to 8 by 3. If you separate these three, we'll get like this. Now substitute the value. It is 59 by 3 minus 3 into 8 by 3. We can write it in simplified way, that is 59 minus 24 upon 3, that is nothing but 35 upon 3. This is your RHL. Now for x is equal to 8 by 3 function is same, means f of 8 by 3 is nothing but 4 into 8 by 3 plus 1, that is 32 by 3 plus 1, which is nothing but 35 by 3. Hence we can say that limit of f of x as x tends to 8 by 3 minus is equal to limit of f of x as x tends to 8 by 3 plus is equal to f of 8 by 3. Hence we can say that therefore f of x is continuous at that point. X is equal to 8 by 3. तो बच्चों हमने आज क्वेश्चन नंबर 3, क्वेश्चन नंबर 4 और क्वेश्चन नंबर 5 के 3 सब क्वेश्चंस आज हमने पढ़े हैं। बाकी के जो भी एक्सरसाइज के क्वेश्चंस हैं आप अपने मन से सॉल्व करते रहो। जो भी डिफिकल्टी है मुझे व्हाट्सएप ग्रुप पे सेंड करो। आई कैन गिव यू इट्स सॉल्यूशन। थैंक यू।